Hey Python enthusiast, coding module here, and today we're delving into the Python class magic. From special methods like repr and iter to building robust class structure with properties and decorator, these tutorials cover it all. We'll demystify class method, explore the simplicity of static methods, and unravel the power of abstract base classes or ABC. So whether you're a Python pro or just getting started, this tutorial is your ticket to mastering Pythonic class design. Ready to elevate your skill? Let's dive in. Remember our credit class? This class contains an init method, which is a special method. And again, how did we know that it's a special method? It's because of the double underscore before and after the method name. And by the way, you can read it as dunder init thunder. And remember in Python, every time an object is instantiated from a class, then it will automatically invoke the init method. So now if we execute this class, and then if we create an object of type credit, for example, is a laptop with an amount of 1200, and if we print this object using the print function, Python will return the object type and the memory location where Python placed this object on the computer's memory. Though this is not a very helpful information, it would be better if Python can make this object readable to human like us. And also, if we try to execute the object without using the print function, it will return a similar output with the type of the object as well as the memory location where this is placed by Python. And in here, I redefined the credit class by introducing a new special method repr. We can also read it as dunder repr dunder. And this method simply returns a formatted string containing the object name and the object amount. So let's execute this class. And then this time, let's create a new object, a keyboard object with amount of 300. And if we print the object using the print function, now it prints the object this time and provide us a more meaningful output. It shows the object name and the object amount. So what happened behind the scene is that when Python execute the print function, it first look for any special method within our class. And this time it found the repr method, so it execute that method and return this output. And here again, I redefine the credit class by introducing another special method, the string or steer method. And this method simply return or print a message containing or saying the amount of the object as well as its name. So now if we execute this modified class, and if we create an object of type credit, for example, this time is monitor with amount of 400. Now, if we print the monitor object using the print function, we can see that this time it prints the message from the string method. And you're probably curious why Python did not invoke the repr method instead. Well, that is because when the print function is executed, Python first look for the string special method. And since that method exists in our class, it execute the implementation of that method. However, if the string method is missing, Python will fall back to using the repr method. However, if we try to execute the monitor object without using the print function, notice here that what Python invoke or execute is the method within or the implementation of our repr method. It's because if we don't use the print function, then Python will automatically look for the repr method instead. And another syntax or way to execute the repr method is by using repr and then open close parentheses and specify the object, for example, the monitor, and here it prints the same output. And similarly, Python also offers a string function that you can use to an object, and it prints the same implementation we have for the string method. Or what you can do, you can again use the print function, and then within the function you can indicate or use another string function and then specify the object that you want to print. So by default again, when print function is invoked, it will first look for the availability of string method and it will execute whatever is implemented on that method. But if, for example, we want to use print function and execute the repr method instead, we can use the refer function inside the print function, and this time it will return the message from the refer method. And another syntax to do this is by invoking the method name from the object, like in the syntax, and if we execute it, it will output the same text from the refer method. And similarly, we can do the same syntax for the string method, and if we execute this, it calls the or return the message from the string method. Well, in summary, what is the difference between string and the refer? Well, string is used for making objects readable to humans, while refer is used for making object unambiguous to the computer. And this is mostly used by developers and in debugging. In Python, we know that if we add 1 and 2, it will return 3, but we don't know what is actually happening in the backend, right? So what happened in the back end when we execute this expression or operation is that Python first identified the data type of these two values, which in this case is an integer. So it calls the integer class. And since Python see this plus operator or plus sign, it invokes the special method add within the integer class and then specify the two values 1 and 2. So if we execute this code, it will return the same result 3. So this expression is almost similar to this syntax. Similarly, if we add two string values like A and B, and if we execute this, it will output AB because when using the add operator to two string values, it becomes a concatenate operations. So what happened in the backend here is Python identified that these two values are string data type, so it calls the string class. And then because of the plus operator or sign, it invokes the add special method within the string class and then specify the two value A and B. So if we execute this code, it also returns the same result. So now let's see how this special method add is related to object-oriented programming or classes. And here we have a sample class savings with one special method in it. So now let's execute that class and then let's create two object of type savings S1 and S2, S1 with 2 pi amount and S2 with 1 pi or 1500 amount. Now if we execute those or after we create those two objects, let's try to add them using the plus operator. And if we execute this code, we got a type error. It's like Python saying that it doesn't know how to add this two object or data type. So the add operation is working on the integer and string class because that special method add is implemented within those class. But if you look to our savings class, this is a custom data type and we haven't implement a special method add. That's why when we try to add these two object from the class of savings, we got this type error. So what we can do to make the add operation work in our saving class is we need to implement or introduce the special method add. So here we also add an additional input argument other. So there we can pass the amount of the other saving object and add it to the amount of the first object. So now if we execute this class and if we create again two objects S1 and S2, now if we try to add S1 and S2 and execute this code, now it returns a correct sum value. It's because now when Python see this plus operations, it goes to the saving class and look for the special method add. And since we have it implemented, now Python knows how to add these two types of objects. Well, all operations in Python has a special method behind the scene, and another one is the sub special method. So here we have a new class method sub with a special sub method, and it requires an input argument other. So any number we pass to it will be calculated by subtracting that number to the object number. Now if we execute this class and create objects from that class, num1 and num2. Now let's try to subtract num1 or num2 from num1. Then Python will return the difference of the two values correctly. Now you need to be aware that Python doesn't know or actually care about on the or how we implement these special methods. What do I mean by that is here we have the method subclass again, but this time I modified the implementation of the special sub method by replacing the subtraction operator by the multiplication operator. Now let's execute this class. Then let's create object from this class, num1 and num2. Now if we try to subtract num2 from num1 and execute this code, it returns 50. We can see that Python or what Python did is multiply the two values instead of performing subtraction. And it's because again Python doesn't know the semantics of subtraction, which allow us to change the implementation of this special method sub. But now if we try to multiply num1 and num2, we got a type error because we don't implement a mul special method within our method sub. Now, in terms of multiplication, we know that for multiplication operation, it can support both integers and float values. So if we try to multiply two float values, it will return a float output. And how Python do it behind the scene is again, it will first identify the data type, the two values, which in this case is a float data type. So it will call the float class and then invoke the special method mul and specify the two values, which is 1.0 and 2.1. So if we execute the syntax, we'll get the same result. And however, if we try to pass two different data type like an integer and a float, this will raise a type error because this syntax only accepts a float value. And here let's see how we can implement the same logic on what happens on this previous syntax that we have here. So here in our saving class, we added a special method mul and add a condition to check if the value passed data type is an int or a float. If a condition is met, we return the product of the object amount multiplied by the other amount. If the condition is not met, then we raise a value error. Now let's execute this updated class and let's create an object of type savings s1 and s2. Now if we try to add s1 and s2, it will work because we have defined a add special method to our saving class. And now if we try to multiply S1 and S2, we receive a value error because we are passing a different data type to the mul method and it only accepts interfloat. It doesn't know about our custom data type savings. For experimentation, if you multiply S1 to the value of 3, this will work because the value 3, when validated by our mul special method is of type int. So the condition will be met and it will perform the multiplication operation. And we can also do it with the syntax by starting with the object and then invoke the mul special method and specify the value. In this example, let's specify a float value, and if we execute that code, it returns a result because that's a valid value. It's a float data type. But what do you think will happen if we start with an integer value and then invoke the mul special data type and specify the object? Well, if you do that, then you will receive an error because Python doesn't know again the S1 data type. It's a saving data type and it only accepts floats or integer data type value. Another operator in Python is the floor division operator using the double forward slash sign. So if we execute this code, it will return 3. So Python identified the double forward slash operator and invoked the special method floorDiv to the integer class because that's the data type of our two values here. So if we do the same operation using the syntax, we'll get the same result. And now we can implement this special method in a class. This time we need to add a special method floor div and use the floor div operator to divide the two number and return the result rounded down to the nearest whole number. So let's execute this class. Then let's create two object of type method floor div. This time we'll use the same values 10 and 3 and assign that to num1 and num2. Now if we try to do the same operation to num1 and num2, we'll get the same result, 3. Another method is the modulo operator, which returns the remainder after dividing the two numbers. If we execute this code, it will return 0 because there's no remainder if we divide 2 from 4. And again, we can do the same operation using the special method mod on the class int. So if we execute this code, we'll get the same result, 0. And similarly, we can implement this special method mod to a class like in this example. So if we execute this class and if we create object of type method mod and assign them to num1 and num2, now if we use the modulo operator to num1 and num2, we'll get the same result, 0. Another special operator available in Python is the power up that uses the double asterisk character. So if we execute this code, it will return 36. And again, we can do the same operation using the special method pow in the integer class. And if we execute this, it will return the same result. And now if we implement the same method or the same special method to our class by using this dunder pow dunder, if we execute this class, then create objects of type method pow and assign them to num1 and num2. If we execute this, now we can use the special method to our num1 and num2 objects. So if we execute this line, it will return the same result. In Python, not just mathematical operators are supported by the special method, even the built-in functions like the len function. So len, when invoked to a string data type, returns the length of the string value, in this case as 4. And we want these functions also be able to support our custom data type, which we can do by using their special method. And string has a special method len, so if we invoke that method and pass a value like test, and if we execute this code, we'll get the same output. Len also supports the list data type, and when invoked from a list data type, it will return the number of elements within the list. In this case, is 7. So now let's see how we can implement the len method to a class. So here we have a class books, and in the init method, we initialize an attribute books to an empty list. Then we have a helper method add book that add new book to the book list. Then we implement a special method len to return the total number of books. Now let's execute this class. So now if we create an object of type book and use the len function, it will return 0 because we haven't add any book yet. And now after adding a book and use the len function again, now it will return 1. Again, after adding a new book and use the len function, now it will return 2. Now, if you want to know all the supported special method of the list data type, you can always utilize the dictionary method. For example, in the list, these are all the special method that support the list data type. Again, special methods are indicated by the double underscore before and after the method name. If you want to know the other special methods that you can invoke from other data type like the integer, again, you can just use the dictionary. For example, on the int class, we can call for the dictionary and all the methods here with double underscore before and after the method name are special methods. Here we have a sample list, and we know that in order to loop through a list, we can use a for loop like this code. So for each iteration, we'll print the number from the list. And for loop is another function that, of course, we also want to support our custom data type. But the question is, how can we implement it? So here we have the participants class, And in the init method, I initialize an empty participant list. And we also have the index property set to 0 by default. Then the add participants method has an additional input argument name that will be appended to the participant list when the method is invoked. We also implement a len function that returns the number of participants. And here we introduce new special methods that supports the iterator function, iter and the next. First, the iter method contains no input arguments, and in this method, the index variable is set to 0, or it's like we are resetting the index value. Then we return the instance of the object using the self keyword. And every time a for loop is executed in Python, it first calls the iter method. Then the next method also has no additional input argument. It first checks if the current index value reached the last participants from the list. If yes, it will raise a stop iteration. Otherwise, it will set the variable p equals to the current participant from the list based on the current index or current iterator index. Then we increment the index value by 1 and return the value of p. If it is a bit confusing, please take some time to review and analyze the code, or maybe you will understand it more once we test this class by creating new objects and then execute a for loop. Now let me execute this class, and here we create an object of type participants, and then we add participants name to the object by invoking the add participants method. So now if we iterate to our participants object using a for loop, it will print all the participants' name. And now if we add a new participant name to the object and again iterate using a for loop again, it will now print all the new participant name including the newly added name George. So now what happened in the background when we iterate using the for loop first calls the participant iter method, which initializes the index variable to 0. Then on each iteration, the for loop calls the next method again and again until it reaches the last element or the last participant, which then trigger a stop iteration from our next method. In case you forgot to add an iter method, then the for loop will raise an error during the iteration. Now, Python also offers the iter and the next function. If you want, you can use this function to our participants object. So if we use the iter function to our participants object, it will return the participant class. Then using the next function to our participant, it will start to iterate to the participant list and print the participant name. It will start with the first element or participant from the list when executed for the first time, and our first participant name is Lily. Then executing this function again and again will continuously print the next element from the list until it reach all the elements, and since we don't validate the iteration, it will raise a stop iteration error. Remember that the standard practice to access and update instance variable is using the getter and setter method. Well, for a quick review, here we have a class coder and the init method has no input argument. And then inside this method, we initialize the name attribute to an empty string. Then we implement a setter and a getter method to access and update the name attribute. Take note as well that part of the standard practice is making the variable private. So here our name attribute contains a double underscore prefix. Now, if we execute this class and if we try to create an object of type coder, if we want to set the name of that coder object, we can just use the object name and then we can invoke the setter method. And now if we want to access the value of that name attribute, we can again use the object and invoke the getName method. But if we try to access the name attribute using this syntax, we'll receive an attribute error because again our name attribute is a private variable. Even if we access that attribute using a double underscore then the attribute name, this will again return an attribute error. because Python will not allow us to access the name attribute using both of the syntax. But if we invoke the dictionary method on the C1 object, here we can access the property of our object, and this also shows the associated key to the name attribute. And knowing that key, we can access the name of the C1 object without using a getter method. So if we execute this code, it returns Jan. And again, that is if you know how to, but again, that is not the standard practice in Python. So here I redefined the coder class and I added a print message on the setter and getter method. And here we have or introduce a property, a name property where we set or where we pass the get name and the set name method. So what is this property for? Well, we'll see that in the next line of code, but we know that invoking the setter and the getter method over and over again, especially if you are going to use that in different attributes, it will become tedious. So there's a way for us to minimize that task, and that is with the use of a property. So let's see how this will help us on that kind of issue. Let me execute this updated class. And now let's create a new object of type coder. We'll store that to variable C. And notice here that if we use this name property, again, this is not a name attribute. Now this is a name property. If we set that to a name with this way, what happened is that it outputs the setter method called, meaning that behind the scene, when we use this name property, it invokes the setter method. That's why it shows setter method called here. And if we again invoke or call that property to know the name of our object, we can use that name, and now it outputs getter method called, meaning behind the scene when we execute this code, it invokes the get name method from our coder class. That's why it also prints the name of our object, which is Elliot. So the property has four input argument. The first argument is the getter function, the second is the setter function, the third is deleter function, and the last one or the fourth one is the documentation or for documentation. So here in our updated coder class, what we have used is the getter and the setter method. That's why we pass those methods to this property function. And so here I modified the coder class by adding a new method, the del name method, and we also added a print function here that shows deleter method is called. By the way, this is a deleter method, so we use the function delete or del, and in this method we delete the name attribute of our object instance. So we can also notice here in the property that we are now passing three methods, including the del name method. Now let's execute this class. Let's again create a new object of type coder, and let's assign a name using this syntax. Remember that we are not directly accessing the attribute name here. What we are accessing here is the name property, not the name attribute that we uh, initialize here. It is the name property. And when we execute that code, again behind the scene, it will invoke the setter method from our class. That's why we have this message printed. Now, if we access that name, it will also shows that behind the scene we are invoking the getter method. That's why it returns Kelly. Now that we have a new function in our class, we can use that function to delete the name attribute from our object. Now if we execute that code, it shows that deleter method called in the backend or behind the scene. So now if we try to access see that name again, we'll get an attribute error because we have just deleted it. Now let's introduce decorators and why it can help extend the functionality of the function or method without directly modifying the code associated to that function or method. So here we have a brand new coder class, and in the init method we added an input argument name, and initialize the name attribute based on that value. And if you notice, we have three methods here with similar name, and each of this method has a decorator indicated on top of the method. So the first method is set as the property decorator, and the second one have the setter decorator. And notice how I declare this decorator. I first indicate the property, which is name, and then followed by the setter method. And lastly, the third method has a deleter decorator. And by the way, we can identify a decorator because it starts with the at symbol or sign. Let me execute this class now. And now let's create an object of type coder. And again, since we use a property, we can access the name using the name property. So if we execute this code, it works the same with how we define the property from the previous topic. But now when we introduce or when we invoke or when we execute this function, it still invoke the getter method behind the scene, and we know that because we have a print function implemented on that method. And now it returns Adam, which is the name of our object C. And similarly, we can set the name by specifying the name. And once we execute it, we can see here that it outputs setter method called, meaning that it behind the scene it invoked the setter method, which is this one. And since we have a deleter method, we can also delete the name using the del function. And after deleting the name attribute, of course, we can no longer access it. If we try to execute this code, we see that it invoked the getter method. However, it wasn't able to return the name of the attribute because we already deleted it. So this class now looks differently compared to the previous structure, but if you notice, the functionality is the same. Only this time we use decorators to define the properties. So this time I redefined the coder class by adding an attribute age, and I also added that as an input argument. Then we initialize these two properties, name and age, with the value passed to this input arguments. So now you can see that I also introduce additional method for the age attribute. So we have three age method here, and then we indicate decorator for each of this method, similar with what we did to the name property. So we also have a property decorator here, a setter decorator, and a deleter decorator. So now let's execute this class. Now again, let's create an object of type coder. This time we need to specify the name as well as the age. So if we execute it, if we want to access the name, we can use the name property, and it says that name getter method called, then it returns John. Now if we want to set the name of this object to a different value, for example is maybe Kevin, we execute that and check the new name value, it now returns Kevin. So meaning the setter method is also working. Now, lastly, we can use the del function for our to delete the name attribute in our C object. So if we execute this, it also says that we invoke the deleter method in the backend. So now if we try to access the name property, we will be getting an attribute error because the object now no longer have that name attribute. Now we can also check the age of our object by using the age property. Here it returns 25, and it shows here that we invoke behind the scene the age getter method. Now we can also set the age to a different value. For example, is 30. Now it calls the setter method. Now if we check again the age value, it should return the latest value, which is 30. Now we can also execute the del function to our age attribute, and once we do that, it will call behind the scene the deleter method. So now if we try to access that attribute, it will say or return an attribute error. So basically, this is one way of using decorators in Python and how this could be helpful to you. But decorator is not limited only to this example that I show you. There are other things that you can do with decorators. There's a lot of benefit using decorator. So what we have discussed so far are methods that you invoke on objects, and those methods are called instance method. An instance method can reference and update the instance state. So for example, in this class, the name and the price, these are the instance state. Another type of methods are called class methods, and these methods are associated with the class itself and not on a specific instance or object of a class. So here we have the credit class again, but this time we made lots of modification. So the init method has two input arguments, name and price, which get initialized when an object is created from type credit. Then we have the raise price method that increases the price based on the interest. And then the print details method shows the credit name and the current price. And below are additional method which are called class methods, and Python identified them because of the decorator class method. And notice that for this type of method, the first argument is called CLS, and this refers to the class itself that allows access to the state of the class. And the getInterest method simply return the current interest value, and then the setInterest method set a new value to the interest variable. Remember that interest here is a class variable or a class state. So now let's execute this credit class. And now let's create an object of type credit. For example, is a laptop with amount of 1200. And interest is a class variable, so we can access it using the class, then invoke the getInterest method. So if we execute this, it will return the interest value, which is 1.04. And we can also access the interest attribute using the object of type credit. In this example is laptop. So if we execute this, it will return the same result. Now we can also update the value of the interest value using the object laptop, and then invoke the setInterest method and specify the new interest value. And then let's invoke the raise price method on the laptop object. And again, if we access the getInterest method from the credit class, it will work. And now it will return the updated value of the interest attribute, which is 1.06. So here we have a hyphenated value, the item name and the item price. And using parsing, we can split the string value using the hyphen as delimiter and then assign the result to the name and price variable. Then after that, we can create an object of type credit and then pass the name and price variable. And once the object is created, we can invoke the print details method on the object, which in this case is phone, and this will shows the credit name and the price of that credit. And now this parsing that we did here, we can actually implement it within our class instead of doing it separately. So here I redefine the credit class by adding a new class method from string, and this method will be doing the parsing for the class and then return the result when the method is invoked. Now let's execute this updated class. Now let's say for example that we have a hyphenated string, this time is iPad with 1300 price. And since our credit class now has a method that can parse this string for us, we can directly create an object of type credit, and then this time we will invoke the from string method and then pass the hyphenated string value, which is contained by the iPad string variable. So once the object is created, we can invoke the print details from the object, and it returns the name of the object as well as the price of that object. So notice here that when we invoke the from string method, it automatically initialize the class and pass the parse result name and price. That's why we have this output here. And now let's delve into another type of method, the static methods. While unlike class methods and instance methods, static methods cannot access the class or instance state. And they are utility methods that make sense as part of the class but have no inherent connection to the class itself. So here we have a simple class credit with a method amount to pay, and this is a regular method. And Python provides a built-in function to convert a method to a static method, and it is the static method function. So now if we execute this code, after converting the method to static, we can use the print function to display the amount to pay for a credit. So if we execute this, this will say that the total amount to pay is 1,260. And what I just showed you is the manual way of converting a method to a static method. And here I redefine the method. This time we use a decorator static method to automatically convert the method to a static method. And with this, we can directly use the print function to display the amount to pay on a credit. And this gives us the same result. So you might be asking, what is the real point of using a static method? Why not just create an object of type credit and invoke the amount to pay method? Remember that a static method has no access to the class or its instance state, and because of that, we can invoke static methods without creating an object or instance of a class. And static methods are helpful in situations where instead of creating a standalone function, we can have that function added as a method to a class. This makes our code more organized, especially if the function doesn't have to access or modify class and instance state. For the final topic on this video, we'll cover or discuss about abstract base classes or ABCs in Python, which are way to define common interface for a group of related classes. And an abstract base class is a type of class that cannot be instantiated itself, and it's only meant to be subclassed by other classes. And these subclasses are meant or required to implement certain methods. And later you will see that on our example, but ABCs are helpful to enforce a common structure among different classes. Now, before we can identify or create the base class, we need to first import the ABC and abstract method from the ABC library. And now to show you the concept of abstract base classes, here I define three classes, the shape, circle, and rectangle. So the shape here is an abstract base class because we use ABC within its open and close parentheses, and it contains two abstract method, area and perimeter. These methods become abstract method because we use the decorator abstract method. And you will notice that we don't have implementation to both of these methods, and we only use pass. That is why it makes no sense to instantiate an object from a type shape because there's nothing we can do about this object if we try, since both this all the methods we have in this class doesn't have any implementation. And the circle and the rectangle are concrete subclasses that inherit from the shape class, which is an abstract base class. And each concrete subclass must provide concrete implementation for the abstract method, area, and perimeter. What I mean by that is because we define the perimeter and area method from the shape class as an abstract method. Now, all of our subclass that inherit from that abstract base class are now required to implement those methods. That's why you can see here from both circle and rectangle that we both have area and perimeter method, and at the same time we have an implementation to both. So now to show you what this abstract base class do to our classes, let me execute this first. And let's attempt to instantiate an object from the abstract base class shape. For example, maybe S1 is equals to shape, and there's no input argument, so we can do something like this. Oh, sorry, I defined a wrong name. Now let's remove that R, and here you will notice that it directly result in a type error because when we define that this class is an abstract base class, it enforces a rule that abstract class should only be subclass and not instantiated. That's why we are getting this error. So now if we want to create an object of a type shape like a circle or a rectangle, we need to instantiate from the subclasses. For example, is circle. So let's try to create an object of type circle and use the circle shape, and this shape requires an input argument radius. For example, let's provide 5, and we did not receive an error, meaning we were able to successfully create an object. Now we can also try to create an object of type rectangle, and this shape requires two input argument, the length and the width. So let's say, for example, 4 and 6, and this is also successful. Now that we were able to create circle and rectangle shape, we can invoke the area, for example, the area method. So let's try that on the circle shape, and this results to 78.5. Now we can also invoke the perimeter by using that method name, and this one result to this value. Now let's also try to invoke the area method from the rectangle. It is also working. And lastly, the perimeter, which is also working. Okay, I just want to show you another example here. I mentioned earlier that when subclasses inherit from an abstract base classes, then that subclass are required to implement the abstract method of the base class. So in this example, maybe I'll just copy this to another code cell. So here, if I try to remove this perimeter method from the circle class and execute this updated classes. Now let me try to create an object of type circle. Let's say a radius of 7. And if I execute this code now, it directly results to a type error. And it says that we cannot instantiate an abstract class circle with abstract method perimeter. And that is because again, this circle class is inheriting from an abstract base class which is shape. And this shape class has two abstract methods. So now this subclass circle needs to have an implementation of both of those methods, else Python will not allow us to instantiate an object of type circle. So the only way to resolve this is again to return the perimeter method, which I will just copy from the previous example. So now if again I execute this updated class and create an object of type circle with a radius of 7, now we don't have any error because we follow the rule. We implement the two abstract method from the abstract base class. So now we can invoke the area and perimeter method from the circle.